All right, number 1, we can multiply 10 times negative 5 to get a negative 50. I'm going to go alphabetical order, so I'm going to go x is next. X to the second times x, that's x to the third. Then I'll go y is next. We have y to the third times y to the negative fifth. Add 3 and negative 5 to get negative 2. Because that's a negative exponent, it's going to have to move to the denominator. The negative 50 doesn't have an exponent, so it can stay up front. You can leave the negative out front if you want. X cubed has a positive exponent. It will stay in the numerator, but the y squared will move to the denominator, become an positive exponent when that happens. Number 2, I can simplify the 6 and the 36 to 1 and 6. There's an a to the 4th there, a to the 7th there. I can cancel out 4 a's, so all 4 of them from the top go away. The bottom, there's 3 left there after I took away 4. For the b's, I can cancel out a b from the top. A b from the bottom leaves me with a b. There's c to the 8th there and c, so I can cancel out a c. So the 1 from the denominator goes away, and then there's c to the 7th left in the numerator. So what am I left with? In the top, I've got a negative c to the 7th over 6 a cubed b. Number 7, we just add like terms. I'm going to go in descending order. Now we have multiple variables here, so descending order is a little bit different. I'm going to actually go x. I'm going to pick x's first, put them first in descending order. So x squared is first. Negative 5x squared, negative 3x squared makes negative 8x squared. Then to descend the x degree, I would do the xy terms next. There's a 12xy and a 6xy, so a total of 18xy. And then last I'll go with y's. So as we descend the x degrees, the y degrees ascend. So they're going up. So 7y squared and negative 4y squared make 3y squared. Now if you have the other way around, the y squareds first and the x squareds last, that would also be acceptable. Number 4, subtraction. Subtract like terms. 6x squared minus 4x squared is 2x squared. Negative 3x minus x is negative 4x. 2 minus negative 3, that's like 2 plus 3, which is 5. Now we get multiplication. We've got it's like an extended version of foiling. Take the w squared and distribute it. So w cubed plus 2w squared. So I just distribute it to that next set of parentheses. Now I do the same thing with the negative 2w. So we get negative 2w squared minus 4w. Now distribute the 4. 4w plus 8. Combine like terms. W cubed. 2w squared, negative 2w squared cancel. Negative 4w plus 4w, they cancel. You're left with 8. So w cubed plus 8. 6. Just like it. Distribute the x. X to the third minus 3x squared y plus 2xy squared. Then distribute the y plus x squared y minus 3xy squared plus 2y cubed. We do have some like terms. I'm going to kind of do it similar to I did number 3. I'm going to go with x's first, descending order, so x cubed. Next would be x squared. I have a negative 3x squared y and an x squared y together. That makes negative 2x squared y. Maybe I'll strike them out as I do them so I can keep track of where I'm at. So next should be the xy squareds. 2 and negative 3 makes negative 1. So negative xy squareds plus 2 y cubed. Number 7, multiple terms in the numerator, one term in the denominator. I need to look to see if there's anything I can cancel from every term. Looks like I can factor out a 12 or cancel out 12 from every term. So 60 divided by 12 is 5, 48 divided by 12 is 4, 84 divided by 12 is 7, and 12 divided by 12 is just 1. Now a's, I see an a squared. There is no a in the next term. So there is not an a in every term. I can't cancel out any a's. As for b's, I have b cubed, b to the 4th, b to the 2nd, b to the 2nd. The most I can pull out is b squared. So cancel out b squared from the first term, leaving me with a b. Cancel out b squared from the second term, leaving me with b squared. Cancel out b squared, that's the entire b squared from there and in the denominator. So what am I left with in my numerator? I have 5a squared b minus 4b squared plus 7a to the 5th. That's all over just a. There's no like terms there, so I'm just going to leave my answer just like so. Number 8. Looks like I can cancel 5 out of everything, so it's a 3, a -1, an 8, a 1, and I can also pull out, looks like r's, the fewest number is r squared, so I'll pull out 2 r's, so r squared, so I have 8 r to the 8th there, r to the 6th there, both of them go away from the third term, and r squared left in the denominator, so in total, 3r to the 8th minus r to the 6th plus 8 all over r squared. It's division. Looks like I can use synthetic division here, so I will. So if we have w plus 3, I would take a -3 in my box. My coefficients, 3, w squared has a 7, w has a -4, my constant is 3. There were no missing terms, so no zeros. Drop your first term down, first coefficient down, you get 3, multiply it by the number in the box to get -9. Add that to the 7, I get -2, multiply it by the number in the box, I get +6. Add those together, I get 2, multiply it by the number in the box, 2 times -3 is -6. Add those together, I get -3. Those are my coefficients in my answer. Let's go ahead and write the answer now. 3 what? Well, we started with w cubes. I divided by w, so we're now down to w squared. So 3w squared, then descend a degree each step of the way. So -2w plus 2, and then for our remainder, -3, and we put w plus 3 in the denominator. Now, of course, that negative, I could just move it in front and call it -3 over w plus 3. That would be okay. But you cannot cancel those 3's because there's not a 3 in the w. I can do synthetic division again on this one. X to the 4th, x to the 3rd, x to the 2nd, x. Constant, I'm counting them all down to make sure there's none missing. There were no zeros. Drop the first coefficient. 1 times 5 is 5. I get 2 times 5 is 10. -1 times 5 is -5. Add those together, I get -2 times 5 is -10 with a remainder of 0. Start with x to the 4th, so now I start with x to the 3rd. X to the 3rd plus 2x squared minus x minus 2, remainder is 0, so we don't need to put the remainder on there. Number 11, I can do synthetic division also. So m to the 4th, m to the 4th, that was m to the 5th. M to the 4th, there is none, so it's 0. M to the 3rd, there's not one of those, it's 0. So 5th, 4th, 3rd. Now 2nd, there's none of those. M, there is a 1, and for my constant, there's a -1. So lots of zeros, don't miss them. They are placeholders, they're very important. Drop your 3 down. 3 times -1 is -3. So I get -3 times 1 is 3. Add those together. 3 times -1 is -3. -3 times -1 is +3, plus 1 is 4. -4 and -1 make -5. So my answer, that was m to the 5th, so now I'm at m to the 4th, so 3m to the 4th minus 3m cubed plus 3m squared minus 3m plus 4, and with my remainder, -5 over m plus 1. Okay, 12. There's a coefficient on the x, so we're not going to use synthetic division. So I'll use long division. Hopefully I have enough room. 2x cubed, 5x squared, minus 2x minus 15. We're not missing any terms, so no zeros. What do I multiply 2x by to get 2x cubed? That would be an x squared. So multiply the x squared, distribute it throughout. 2x cubed minus 3x squared. Just subtraction. I'm going to think of that as adding the opposite. So I can turn that into addition as long as I distribute it throughout. I'll do a different color just so it kind of shows up. 2x cubed cancel. I get 8x squareds. Drop the other terms. Repeat the process. To get from 2x to 8x squared, we need a 4x. So distribute 8x squared minus 12x. Distribute the negative. we get 10x minus 15 multiplied by 5, 10x minus 15, distribute the negative, that cancels, I'm left with a remainder of 0, so x squared plus 4x plus 5 is the answer. No remainder. Alright, go to the back page. Plug in -2. So 2 times -2 squared minus 4 times -2 plus 3. Order of operations, -2 squared is 4, so that's 2 times 4 minus 4 times the -2 plus the 3. So now I can do my multiplication. 2 times 4 is 8. -4 times -2 is positive 8 plus 3. 8 plus 8 is 16. 16 plus 3 is the 19. So P of -2 is 19. For number 14, P of 3a. So -2 times 3a cubed plus 5 times 3a minus 2. So 3a cubed, you have to cube the 3 and the a both, so we get 27a cubed. Now we can do the multiplication. So times -2, so we get -54a cubed plus 15a minus 2. There's no like terms, that's the answer. State the degree. Degree is the largest exponent, that's the 3. And the leading coefficient, I'm going to abbreviate the LC here. Leading coefficient is the coefficient on that term, which is 4. The next one's actually out of order, so you may want to rewrite if you want. The largest exponent is the 7th, so that term comes first. And then descend your way down, so minus 2y cubed plus the 4y minus the 6. So degree is the largest exponent, that was 7, and its leading coefficient was -10. Alright, this one's a little funky because we've got multiple variables. So for the degree, that's the largest exponent. It's when there's two variables, like the x squared y cubed, the x squared has a degree of 2, the y cubed has a degree of 3, so together it's a degree of 5. That term has a degree of 5, this term is a degree of 2, of 4, and is 0, so the largest one is 5. And so then its leading coefficient, the term that has the 5, its leading coefficient was -4, or its coefficient was -4, so that is the leading coefficient. Alright, now, number 16, describe the end behavior. So that's how we write, as x approaches infinity, what's f of x going to approach? I'll come back and finish it, but let me get also, as x approaches negative infinity, f of x approaches. So this notation is kind of strange, but realize x-axis is the left-right axis. So as x approaches a positive infinity, that means we're moving to the right. So as we're moving to the right, look at what happens to the graph as we move to the right. So we look at the very right side. Where is it pointing? Well, it's pointing down. So the y, the f of x, is heading towards a negative infinity. So I'd put a negative infinity here. And then as x approaches negative infinity, that's as we travel to the left. So what's the left side doing? Well, it's pointing down also. So it's also traveling to a negative infinity. So that's our end behavior for number 16. Part B. Odd or even. Since both sides are pointing the same direction, that means it's even. See, the number of real zeros. How many x-intercepts are there? Well, there's 1, 2, 3, 4. So there's 4 real zeros. D. Determine if it's positive or negative leading coefficient. To determine that, you look at the right end. The right side, it was pointing down. That means it's negative. If it was pointing up, it would be positive. Okay, number 17, and behavior. So as x approaches positive infinity, what does f of x do? And as x approaches a negative infinity, what does f of x do? Well, x approaches positive infinity means we're moving to the right. Look at the right side, it's pointing down. So f of x points to negative infinity. As x approaches a negative infinity, that means as we move to the left, look at the left end, what are we doing? It's pointing up. That'd be towards positive infinity. Odd or even? Well, the two sides are pointing different directions. That means it's odd. Number of real zeros. How many x-intercepts? 1, 2, 3. Positive or negative leading coefficient. Look at the right side. Remember, not the left. It's always the right. The right side's pointing down, which means it was negative. Okay, we're doing use the degree and end behavior to match the polynomial to the graph. Okay, so as I look at number 18, it's even, which means both sides should be pointing the same way. The leading coefficient is a positive number, which means the right side's pointing up. And since they both point in the same direction, both sides should be pointing up. So not A, not B, not C, has to be D. It's the only possible option. Number 19. It's also a degree of 4, so it's even, so both sides are pointing in the same direction. Since A is negative, the right side goes down, so the left side is also. So both sides are pointing down. Could be A, could not be B, could be C, not D. So we're down to A and C. The difference is C is a parabola. There's no extra little wiggles. Like if you look at A, there's the extra little wiggle. This is a degree of 2 if there's no extra wiggles. This one has an extra wiggle. That must be the degree of 4, the fourth degree. So A should go with number 19. Let's continue. Number 20, degree of 3. It's odd, so one side goes up, one side goes down. The leading coefficient is positive, so the right side goes up. If the right side's going up, the left side must be going down. Look at B. Right side's going up, left side's going down. That's odd, so B goes with number 20. And 21, x squared. It's even. It's also a quadratic. It's a parabola with an A value that's negative, so it's pointing down. The parabola that's pointing down is C. All right, thanks for watching.